Examine this topology. What do you see? Well, I see 4 different VLANs. But what does that mean? Well, on our Cisco Catalyst switches, we are running per VLAN Spanning Tree Plus by default. And even if we change it to Rapid Spanning Tree Protocol, we will still end up with the same scenario. And that is 1 spanning tree instance for each and every single VLAN. So we have 4 VLANs here. It means we have 4 different spanning tree instances. We'll have a spanning tree instance for VLAN 11, 12, 21, and 22. And by default, they'll all have the same root bridge. So let's say this is the root bridge. Designated port, root port, designated port, block port. It's pretty much what the topology could potentially look like without getting into the actual numbers in this particular case. So they're all the same. All 4 instances of Spanning Tree Protocol. Let's say, though, we decide to make our switch on the left-hand side the root bridge for VLANs 11 and 12 only, and the switch on the right-hand side the root bridge for VLANs 21 and 22. So now we have 2 different root bridges. We have manipulated the spanning tree topology. And in this case now, VLANs 21 and 22 will have these as designated ports. This is a root port. This is a root port. And let's say this ends up being the designated port, and this is the block port in this case. So that's the spanning tree topology that we would see for VLANs 21 and 22. In reality, though, we have 4 spanning tree instances running, 1 for each and every single VLAN, but how many tree-like structures do we have? Right, when you look at the topology, how many are there? There's really only 2, isn't there? There really is only 2. Let's amplify this scenario, and let's say we have 500 VLANs instead. 500 VLANs. So our root bridge on the left-hand side is responsible for 250 of them, and our root bridge on the right-hand side is responsible for the other 250. How many spanning tree instances would we have running? 500 in total, 1 for each and every single VLAN. But step back a moment. How many different trees do we have? There's still only 2 different trees. But since there's a different spanning tree instance for each and every single VLAN, if a topology change happens, the switches have to calculate on a VLAN by VLAN, spanning tree instance by spanning tree instance basis. So we could have 500 different spanning tree instances that have to be recalculated if an issue happens within our topology. And that can be very resource intensive. So since we have these similar tree-like structures for various VLANs, why not group them together into the same spanning tree instance? Meaning, all the VLANs that are using this as the root bridge, and all the VLANs that are using this switch as the root bridge, why not have them in their own groups that are then associated with a spanning tree instance? Meaning we could have all 500 of the VLANs, but 250 of them are represented by a single spanning tree instance, and the other 250 are represented by the other spanning tree instance. So now only 2 spanning tree instances running. Only 2 running. But we still have 500 VLANs. And that's what we get with multiple spanning tree protocol. Multiple spanning tree protocol. It is an IEEE standard that is based on an original design by Cisco, and it is known as 802.1s. And the great thing about it is it's backwards compatible with other spanning tree protocol forms. So you can do a slow migration as you implement multiple spanning tree protocol in your environment. It can communicate with 802.1d, 802.1w, so spanning tree protocol and rapid spanning tree protocol, so no issues there. In addition to that, it is based on rapid spanning tree protocol. So all the great features, all of the great rapid convergence that Rapid Spanning Tree Protocol provides is all baked into Multiple Spanning Tree Protocol. So this is typically something you will end up using if you have deployed end-to-end VLANs. There's a lot of VLANs all over the infrastructure. You can have users in VLAN 11 over here, VLAN 300 over there. So it's typically used with end-to-end VLANs. If you are following the Cisco Enterprise Campus Architecture design with local VLANs, you will have a smaller number of VLANs, and your VLANs will be more controlled. And as a result, you could get away simply with using Rapid Spanning Tree Protocol when you are using the Cisco Enterprise Campus Architecture. But if you're not, and you are deploying a large number of end-to-end VLANs, you might want to consider using Multiple Spanning Tree Protocol to reduce the overhead of Spanning Tree Protocol on your switches.